But before we get started, any questions, anything? Due dates, I already answered that question. It's due every Monday, 10 p.m.
10 p.m.?
Yeah, 10 p.m. Just need to upload it. So what's going to happen is at 10 p.m. I will go to the websites and copy and paste, print the website into PDF to my hard drive, and I will grade it, the comments on it, and send it back to you by email. That's what's going to happen. If at 10 p.m. it's not there, so you have to probably do it earlier, especially for the ones who are new to Composer. It's not difficult. I just want to let you. So only one has used it. Yeah.
Yeah, I was in that same boat.
Yeah. What I want to say is, after you have used it for a long time, there are a lot easier ways. But you know, as a beginner, it's difficult to sometimes to get a correct way to organize all the files. It can be really simple if you look at all the tutorials, the long tutorials, how I made it. I mean, it's so many figures and narratives. So I just, you know, if, for example, I need a figure to be put in the HTML, right? I'll just do a snipping tool. For naming the files, it just make it easier. I just name it and Control S, right? Then just save it on desktop for now, and just call it F1. I just type f1.jpg. Done. The figure is done. And then you want to open up a website file. You can start from the text editor. Okay, just call it test, but just need to change the extension of it, HTML. Okay. You just pay one tuition for digital, and you are learning website design as well. Worth it. So I got a website, and go to Composer, and I got a comment from last semester. He forces me to use 20 years old. That was that you? He forced us to use a 20-year-old HTML editor, and it takes me like 20 minutes just to get the editor done instead of focus on the report. He probably didn't follow the tutorial. Okay. No, it's not. It's not actually. It's pretty good. Just follow whatever I'm recording, right? I'm recording this. Just follow what I'm doing now. Just follow this. Very simple. You can see how fast I can get it done in just a couple minutes. Just open it up as a website. It's blank right now, okay? And I just type blah blah blah. There's a report, and then I need to insert a figure. I refer to figure 1. I just go to image. I click this one, right, and find the location. If you have your HTML file and your image file in the same folder, you don't need that directory. You don't need all the paths to that directory, right? It just, what's the name of the figure? Yeah. Okay, so it's going to show up here if you have the correct path. And since they are in the same directory, so you don't have to do anything. Okay, and just check this box. And you want to resize it, just come here and resize it. If you feel it's too big, and resize it. Save, close. And here's the report. Okay, and then I highly recommend, so for each labs folder, you don't want 20 figures, you know, in the same folder with your HTML file. Sometimes you have to look at which one is a website file, which one is a figure. Take a picture and then save as a picture. Yeah, as a picture, like what I did over here.
And then you wanted us to change all of our settings for LT Spice to get our figures to look nicer. If we have our screenshots, because we did them in the lab, if we took screenshots there and it's not all fancy,
they can.
Should we do it or?
No, just do it next time. Just make it nicer next time. So again, it's not required. I'm not going to take any points down if you are not, you know, not making it nice. Just to get it finished. But for the paper versions, right, for the homework assignment in the future, there might be some simulation assignments, and you don't want to get something printed out and you feel still white. So much print on that, right, or ink on it. I just change it to a lighter color.
Mine to an off-white, so it still uses all the ink, but it looks the same as the paper.
And Okay, so what I usually do, I create a figure, I just call image, IMG. You just want to make it short and put it here, okay? And then you open it up, it's not there anymore because you have to change the path. You have to go to Composer and simply change the path. Come here and single click, go to image, and just add IMG there. Okay, and it's going to show up and come back here. And here's the report. Okay. Make sure you have all the necessary sections. Introduction, methods, results, discussion. Can be short, but you do need it. For now, it's very simple. You may think it's not necessary, but I just don't want to, you know, all the reports from different people all look different. It just looks bad. During the ABAC review, when the evaluator work here, we have to have student work samples and put in the binder and give it to them for review. It's going to be nice to have a same format for each report. Okay. I'll take points off if you are not following the sections, if you are missing a discussion section, even though you just put one sentence there. This is a great lab. Seems like that, right? So what you have learned. So you can say, I did, at the very beginning, I did this, what was wrong, so I changed it and it started working. It also can be used as a note for you in the future to come back and review. This helps. Okay, I hope this helps. If you still couldn't do it, come back to this recorded video. Did you watch the video or look at the notes? Probably yes, right? To prepare for the quiz. You all know my website, right? Okay. So I hope I won't see any comments saying like he forced us to use a 20-year-old. It's just a nice free tool. And you cannot blame too much. Did you pay for that? You didn't. Why do complain so much? It's not bad. It's not bad. Yeah.
LT spice during logic was rough when there was CMOS transistors. But now it's fine.
You got used to it. It's good. So it's linear technology was acquired by ADC, I guess. AD. So analog devices, which is one of the biggest companies in the industry. So they acquired LT Spice, and I think it's a really legit simulation tool. Anyway. So based on the past experience, if you wait until it's already Friday, if you don't have time, what's gonna happen? I mean, if you do have issues, feel free to send me an email. But in the future, do not ask any questions relating to the website, you know, on Friday. But you can ask on Monday if you want. Couldn't make it out, figure it out. If you have time, I can probably still help. But during the weekends, I couldn't guarantee that. Sometimes I don't have cell access. So, all right. What's going to happen is usually if you have issues with the websites, just let me know. I just get it, log into the folder. I can see everyone's folder. So I will solve the problem for you and tell you what's happening. I won't just say like, do this, and just do it by yourself. I will just solve the problem for you and tell you what's next. As you guys are computer engineers, are super smart guys. I don't want to spend too much time on it. Okay, let's get into the materials I want to cover this for today. It's a pretty exhausting week. Usually, it's the first week is always like that. You guys still have like 2 to 3 years at least to go to school. It's tough. I'm done. Yeah, it's also very exciting, right? Just learning all the new things. You have curiosity in this area. Answers a lot of questions you have. Okay. Something regarding DACs. two examples first. Find the resolution for a DAC if the output voltage is desired to change in 1 millivolt increments while using a reference voltage of 5 volts. It's like someone is designing a DAC, and the customer said, at least your DAC need to change, so the output has to change in the 1 millivolt increments, which means the smallest step it is able to resolve is 1 millivolts. Okay, if you are asking like if this one can do a 0.5 millivolts increment, no, that's the lowest voltage it is able to resolve. So what's how many bits do you need for that DAC in order to resolve a 1 millivolt whenever you have a reference voltage to be 5 volts? Yeah, we have to do the calculation. So 1 millivolt. So for example, we are treating 1 millivolt as the smallest step. So right. So you have a full range here, and to resolve, for example, 5 volts for the full range, and your DAC or ADC has to resolve every single step here, right? So many, and the smallest step must be 1 millivolt. You know what I mean? So how many bits do you need to achieve that? So let's assume 1 millivolt is LSB, least significant bit. The voltage to the one LSB, okay, is 1 millivolt. So 1 millivolt over 5 volts, which is the full range, there's no meaning for this division, it's just a ratio. Okay, 1 millivolt over 5 volts should be 1 bit. This is just 1 bit over how many bits? N bits, right? 2 to the nth. That's so many steps. This is that many steps in there. So 1 over that, because 1 is 1 LSB. And 1 millivolt is the voltage version of 1 LSB. And the full range. That's the number of steps you have. So for this equation, you can solve for n from here. And this is given. So this equals 0.002. Okay, so 0.002 equals this. And 1 LSB, what's the unit? Is that 1, just 1? This is 1 LSB, right? So for the whole range, you have 2 to the nth LSBs. Does that make sense? So this equals this, and then so n equals what? Log base 2, 1 over 0.002. That's 3 zeros. So you can solve for n. And what is that? So this equals 12.29 bits.
So in that case, would you round down or not?
What you think?
Probably obviously a higher resolution.
Yeah. It's always good to have a higher resolution, as long as your circuit can run that fast. Okay. So a 13-bit DAC will be needed. That's the first example. Any question on this? So there's a similar problem in the homework assignment, which is due next Friday. Okay, should be able to do that after this. One more example. Find the number of input combinations values for 1 LSB what's a counterpart for 1 LSB for LSB? So still remember in logic? Yeah, MSB, most significant bit. This is the least. Good. And full scale voltage generated. Voltage generated for a 3-bit, 8-bit, and 16-bit DAC. And given that our EF, our ref, is 5 volts, let's just make a table out of it. Resolution. When people ask for resolution for ADCs or DACs, what are the answers? Input combination. One LSB V full scale. A table here. So again, when people ask for the resolutions for ADCs or DACs, what are the answers look like? What's the resolution of ADC? So you're expecting something like very good resolution. What does the answer look like? What you want to answer? I mean, during the interview, they're asking, oh, you have used some ADCs for a project. What are the resolutions? Was there a very good resolution? I could remember, just very good. Really good job, yeah. What are the answers? How many bits? I used a 10-bit ADC for my project, 12-bit. So 10 is 10-bit a good ADC? Huh? Yeah, it's pretty bad. So it's integrated ADC in Arduinos, which is only $2 and can be even lower. 10-bit ADCs, and very slow.
Why 10-bit? It's such like a weird middle number.
10 fingers. What we like.
But for all like computer stuff, it's like 2, 4, 8, 16. 10 just feels so out of place.
But it's 10 to the 10th power.
Okay.
Yeah. You know what? It started with 8-bit ADCs, and people are starting getting more resolution. They're thinking, I mean, let's add a couple bits, a couple of bits. Then let's just add 2 to it. I think. I don't know. So 10-bit probably is not adding too much workload after 8 bits. But it's not too bad as well, I guess. Just good for everyday applications, just a temperature sensor or something. So another question can be an interview question. How many steps do you have in there? How many stages do you have for a 10-bit? Or they can probably just ask you, they can directly ask you. If I'm interviewing some computer engineers, I'm going to ask you, what's the decimal number of 10 to the 10, 2 to the 10s? If you're thinking, you guys are fake computer engineers. Seriously, you are not trained in my lab. If you work with me in my lab, when you graduate, you won't be like that, okay? But now, still, but seriously, that's why I keep saying I can use one simple question to test if you're fake or not. You put like 10 projects on your resume, I'm just asking you, what's 2 to the 10th power? 1024. So you're not fake. No. So I'm going to ask you again, what's 2 to the 10th? Okay, cool. Keep in mind, okay? So what's the resolution of the ADC on the Arduino chip?
10 bits.
Yeah. Is that good or bad? Yeah, it's fine. Yeah, it's okay for temperature sensing. But if I'm doing a capacitance sensing or anything else I can think of, do we need a high resolution or ADC for temperature? Like, usually not, right? Do you really care about 0.01 degree change? You do, you can feel that. Yeah. Acceleration is one example. You need a high resolution for acceleration. Force, okay? Skills, force. And capacitance is something really need a super high resolution. So the one I use is 24-bit. Is that 24-bit? I think it is. When I was in graduate school, there's a chip from AD, which is the company. So the ADC inside the capacitor to digital converter, I think it's 24-bit. You are thinking 20 from 10 to 24 is not a huge change, but it is. You can imagine it's a huge, very high resolution ADC. When I was working with that capacitive to digital converter on the bench, I have to hold my breath. I probably told you guys. When I was dealing with that, when I was pipetting some of the liquids on the fluids on the chip, I have to hold my breath when I'm trying to read an accurate capacitance value out of that ADC. If I move a couple of picofarads change, you know, I have to hold. Probably I forgot if I wear a mask, but I have to be really careful about that. So any airflow is going to change the capacitance on the board, and the ADC is going to detect it. Super high resolution.
Do ADCs work the same way, I assume? Like with resolution, so you have like 8, 16-bit ADCs?
Yeah.
What's the oscilloscopes that you?
Their ADCs? I don't know. Must be pretty good because you can detect millivolts really well, not stars.
Right.
Yeah. Yeah, so the oscilloscopes are actually DACs, data acquisition systems, right?
I was thinking.
No, sorry, DAQ. Anyway. Resolution 3, 8, 16, what? Bits. How many input combinations you can have for 3-bit DAC? How many input combinations? Right? Another question, what's the 2 to the 8th power? It's not too late. Okay, it's okay. Yeah, 256. This is not required. You don't have to know that. Oh, was a cap? I don't know. I don't want to say like what I know is going to be the cap.
What's the
Yeah.
highest you could just spit out?
10. I just barely passed the interview. That's why I'm teaching here.
I guess those you can't do, right?
If I'm teaching logic, I am teaching logic, but it's online. Since it's online, I don't have to talk. So I couldn't review whatever I have taught. But I think if I'm teaching that, doing all the writings every semester, I probably can get like 2 to the 12th, only 2 more after 2 to the 10th. I don't know. So 2 to the 16th, it's going to be 65536. All right, it's 5 volts. What's one LSB over here? So what is 1 LSB for? Which means 1 LSB voltage, right? If you have 5 volts, you have this much. What's 1 LSB? What's the smallest voltage it is able to resolve? So just use 5 over 8, which is 0.265 volts. And 5 over 256 is going to be 19.5 millivolts. So whenever you are looking at, so you can see if you use the 8-bit DAC, that's the smallest voltage you can output from the DAC. So depending on the application, you might be able to make a judgment on how many bits do you need. And for this one, it's 5 over 65536, which is 76.29 microvolts. Okay. So have some concept over here. Is 1 microvolt, is 1 millivolt detectable by the oscilloscope? Is 1 millivolt very small, or let's say 10 millivolts? What about 10 millivolts? Could your oscilloscope display 10 millivolts really well? Yes, you can. Yes. What about 1 millivolt?
Yeah.
Barely.
The oscilloscopes we have here go to 20 per grid.
Yeah. But 1 millivolt, you can still display it, but it's getting really noisy.
Yeah.
So just let you guys know that 1 millivolt is really pretty much one of the lowest voltage you can really see in the decent quality in the oscilloscope. So the millivolts signals are super small. And it's going to be interfered by all the different noises around in the environment. And you want to really see these microvolts signals, what you have to do. What do you have to do with it? Are there microvolts signals? Are there microvolt signals? Definitely, yes, microvolt signals. Not really common, but yes, from the sensors. Some of the sensors are outputting microvolts, but they usually have to pre-amplify everything before you can make the connections, since they're not asking customers to design the amplifiers. They have to put all the amplifiers well designed on the board and sell it to you with all the sensors. So if the microvolts signal being pre-amplified, you are probably getting, 1 volt or a couple hundred millivolts, and then you'll amplify it again by your amplifier, whatever you can build. Then it's going to be very easy to handle because it's already in the 100 millivolts level. Can easily display. If you don't amplify, it's okay. You can still display it on the oscilloscope. So 76 something point something microvolts is already very small. Keep in mind, it's way smaller than one millivolts. So a lot of times you have to amplify it in order to visualize it. Okay. So what are these full scale voltages for these resolutions? You remember what's the equation for that? Full scale.
To the n minus 1 or V reference.
Okay. Yeah. And then times. Wait, do I have to time anything?
Yeah, V ref.
Yeah. Right. So I'm not going to do the calculation for you, but I'll just write it down directly. 375 volts. I mean, you can compare from here to 5 volts. I are losing a lot of voltages. The resolution is poor. 4.985. 4.999 volts. So you can see it's not losing, pretty much not losing anything. It's very close to the VREF, to the whole range. So you are using pretty much the whole range from the VREF. We got 4 more minutes. See what I can do. I don't want to rush, it's Friday. Make it easy. Anything here won't be able to cover in 3 minutes. I won't rush. It's not working. I'm experienced, I'm a seasoned professor. Okay. Open up there. No.